Imagine a planet that was once similar to Earth, a world where rivers once flowed, lakes existed, and perhaps even oceans covered its surface, a place that may have once supported life. Today, that same world is a frozen red desert, where temperatures can drop to minus 120 degrees Celsius, and the atmosphere is so thin that a human would lose consciousness in seconds. This planet is Mars. And yet, despite how hostile it is today, Mars remains the most realistic candidate for humanity's future beyond Earth. Not Venus, not the Moon, not the icy moons of Jupiter or Saturn. Mars. But why? What makes this cold, barren world so special? The answer lies in its past. Mars is the only planet in our solar system that is both similar enough to Earth and close enough for us to realistically reach and transform. A Martian day lasts just over 24 hours, almost identical to Earth's. It has seasons, polar ice caps, and clear geological evidence that liquid water once flowed across its surface. Ancient riverbeds, dried lake basins, and minerals that only form in water tell us one thing clearly. Mars was once warm, wet, and possibly alive. And that changes everything. Because if Mars was once habitable, then in theory it could be made habitable again. This idea is known as terraforming, the process of transforming a hostile planet into one that can support human life. Not through domes or underground cities, but through planetary scale engineering, creating a thicker atmosphere, raising temperatures, and eventually allowing liquid water to exist on the surface again. It sounds like science fiction, but many scientists believe it is physically possible. The real question is not can we, but how long would it take and at what cost? Today, Mars is a shadow of its former self. Its atmosphere is more than 100 times thinner than Earth's. It cannot trap heat. Solar radiation constantly bombards the surface, and without a global magnetic field, the planet has no shield against the solar wind, which slowly strips away any remaining gases. This is why Mars became cold and dry in the first place. Billions of years ago, its core cooled, its magnetic field collapsed, and the atmosphere slowly leaked into space. So the challenge is enormous. To terraform Mars, we would first need to warm it up. One proposed method is to trigger a massive greenhouse effect. By releasing carbon dioxide trapped in the polar ice caps and soil, temperatures could rise, which would then release even more gas, creating a self-reinforcing warming cycle. Some scientists have proposed using orbital mirrors to focus sunlight onto the poles. Others suggest releasing artificial greenhouse gases far more powerful than CO2. In theory, this could raise global temperatures by dozens of degrees. But even that may not be enough. Mars simply doesn't have much atmosphere left to work with. And even if we somehow create a thicker one, it would slowly leak into space again without protection. That's where one of the most ambitious ideas ever proposed comes in, creating an artificial magnetic field. Some scientists have suggested placing a massive magnetic shield at a stable point between Mars and the Sun, deflecting solar wind and allowing the atmosphere to rebuild over time. It sounds like pure science fiction, yet the physics behind it are real. The scale, however, is beyond anything humanity has ever built. And then there is time. Terraforming Mars would not take decades, it would not take centuries, it would likely take thousands of years. Generations of humans would have to commit to a project they would never live to see completed. This raises an even deeper question. Should we do it at all? Some argue that we have no right to alter another world, especially one that may still hold traces of ancient life. Others believe that expanding beyond Earth is essential for the long-term survival of our species. Mars could become a second cradle of humanity, or our greatest mistake. What makes this question so powerful is that it forces us to confront who we are as a civilization. Are we explorers, builders, and shapers of worlds,
Or are we caretakers, meant to preserve what already exists? Terraforming Mars is not just a technological challenge, it is a moral one.
Quest for knowledge. In the previous part, we explored why Mars is the most realistic candidate for humanity's second home, and how it may have once been warm, wet, and potentially alive. Now it's time to go deeper. If we truly wanted to terraform Mars, how would we actually do it? What technologies would be required? And how far are we from making them real? The first and most critical step in terraforming Mars is warming the planet. Right now, Mars is cold not just because it is far from the sun, but because it cannot hold on to heat. Its thin atmosphere lets warmth escape almost instantly. So the goal is simple in theory: thicken the atmosphere and trap more heat. In practice, however, this is one of the greatest engineering challenges humanity has ever faced. One of the most discussed ideas is triggering a massive greenhouse effect. Mars still contains frozen carbon dioxide trapped in its polar ice caps and beneath the surface. If that CO2 could be released into the atmosphere, it would trap heat, raise global temperatures, and begin a feedback loop. Warming leads to more gas release, which leads to even more warming. Over time, this could push Mars into a new climate state. But how do you release that gas? One proposal involves orbital mirrors, enormous reflective structures placed in space to redirect sunlight toward the Martian poles. These mirrors would concentrate solar energy, slowly heating the ice caps and causing them to sublimate directly into gas. Another proposal involves deploying factories that release powerful synthetic greenhouse gases, far stronger than carbon dioxide, capable of warming the planet much more efficiently. If successful, this process could raise Mars's temperature by tens of degrees. Ice would begin to melt, water vapor would enter the atmosphere, dust storms would become more intense. The planet would start to change, slowly but measurably. However, warming Mars is only the beginning. Even if we manage to thicken the atmosphere, it would still be unstable. Mars lacks a global magnetic field, which means the solar wind constantly strips away atmospheric particles. Without protection, any new atmosphere would eventually leak into space, undoing centuries of effort. This is where one of the boldest ideas in planetary engineering comes in: creating an artificial magnetic shield. Scientists have proposed placing a massive magnetic generator at the L1 Lagrange point between Mars and the Sun. From this position, it could deflect charged solar particles, essentially acting as an artificial magnetosphere. Over time, this could allow the atmosphere to stabilize and even rebuild itself. It sounds like science fiction, but the physics behind it are real. The challenge lies in scale. The energy required would be immense. The construction would be unlike anything humanity has ever attempted. It would be a project spanning generations, perhaps even civilizations. And then there is the issue of oxygen. Even if Mars becomes warm and protected, its atmosphere would still be mostly carbon dioxide. Creating breathable air would require biological transformation on a planetary scale. One idea is to introduce genetically engineered microorganisms, bacteria or algae capable of surviving harsh conditions while producing oxygen through photosynthesis. Over centuries or millennia, these organisms could slowly change the chemical makeup of the atmosphere. But oxygen alone is not enough. Humans evolved under Earth's gravity, pressure, and radiation levels. Mars's gravity is only 38% of Earth's, which could cause long-term health problems like bone loss, muscle atrophy, and cardiovascular issues. Even with a breathable atmosphere, living on Mars might never be truly Earth-like. And this leads to an uncomfortable truth. Terraforming Mars may never result in a second Earth. At best, it may become a partially habitable world, one where humans can live with assistance but never quite naturally. So why even try? Because terraforming is not just about Mars. It is about learning how to control climate systems, how to manage planetary ecosystems, and how to survive beyond our home world.
The technologies developed for Mars could one day help us stabilize Earth itself, repair climate damage, or protect our planet from cosmic threats. But then there is a moral question that cannot be ignored. What if Mars still harbors microbial life deep beneath its surface? Would terraforming wipe it out before we ever discover it? Do we have the right to reshape an entire world simply because we can? Some scientists argue that Mars should be preserved as a natural laboratory, a record of early planetary evolution. Others believe that spreading life is a moral good, and that turning a dead world into a living one is a form of creation, not destruction. This debate has no easy answer. Terraforming Mars is not just a scientific challenge, it is a philosophical one. It forces us to decide what kind of species we want to be: explorers, guardians, or conquerors of worlds.
If humanity were to succeed in terraforming Mars, the planet would not simply become a second Earth. It would become something entirely new, a world shaped by human intention, technology, and adaptation. So what would life on a terraformed Mars actually look like? How would people live, work, and evolve on a planet that was never meant for them? Even in its most optimistic future, Mars would remain different. Gravity would still be only about 38% of Earth's. This alone would change everything. Humans born on Mars would grow taller and more slender. Their bones would be weaker, their muscles less dense. Returning to Earth might even become impossible for them. Over generations, Martian-born humans could slowly diverge from Earth-born humans, not just culturally, but biologically. Cities on Mars would not look like those on Earth, at least not at first. Early settlements would likely remain partially enclosed, protected from radiation and pressure fluctuations. Architecture would favor domes, underground habitats, and structures carved into rock for natural shielding. Over time, as the atmosphere thickened and radiation levels dropped, open-air environments might become possible, but the planet would always demand adaptation. Daily life would be shaped by scarcity and precision. Every resource, water, air, energy, would be carefully monitored. Waste would be recycled with near-perfect efficiency. Nothing could be wasted on Mars. In many ways, it would force humanity to become more disciplined, more sustainable, and more conscious of its impact on the environment. Agriculture would be one of the greatest challenges. Martian soil, or regolith, contains toxic compounds and lacks organic matter. Crops would initially be grown in controlled environments using hydroponics or aeroponics. Over time, genetically engineered plants and microbes could be introduced to slowly enrich the soil. Farming on Mars would be less about fields and more about ecosystems engineered from the ground up. But perhaps the most profound change would be psychological. Mars is far. Communication with Earth would have a delay of up to 20 minutes each way. There would be no real-time conversations, no instant help. Colonists would need to be deeply independent, emotionally resilient, and capable of solving problems without outside support. In many ways, they would be pioneers in the truest sense of the word. Culture on Mars would likely evolve differently. Art, music, language, and traditions would reflect isolation, survival, and a deep connection to a harsh but beautiful world. Over generations, Martian society might develop its own identity, no longer an extension of Earth, but something new. And then comes the question of governance. Who would own Mars? Would it belong to the nations that reached it first, to corporations, or to humanity as a whole? Current space law forbids national ownership of celestial bodies, but it does not clearly address permanent settlement or terraforming. New political systems might emerge, shaped by necessity rather than ideology. There's also the question of inequality. Who gets to go to Mars? Who decides who is worthy of becoming a citizen of another world? If only the wealthy or powerful have access, Mars could become a symbol of division rather than hope. The ethics of colonization would follow humanity into space. Yet despite all these challenges, the idea of a living, breathing Mars continues to inspire scientists, engineers, and dreamers alike. Because beyond survival,
Mars represents something deeper, a second chance, a chance to learn from Earth's mistakes, a chance to build a civilization that values balance, sustainability, and long-term thinking. But perhaps the most important question is this: if we succeed in terraforming Mars, will we have truly learned how to care for a planet, or will we simply repeat the same mistakes on a new world? Terraforming Mars is not just about changing a planet, it is about changing ourselves. It forces us to confront our limits, our responsibilities, and our future as a spacefaring species. And in the end, the fate of Mars may tell us more about humanity than about the planet itself. Whether it becomes a thriving second home, a scientific outpost, or a cautionary tale will depend not on technology alone, but on the choices we make along the way.
As centuries pass and Mars slowly transforms, the question is no longer can humans live there, but who will they become? A terraformed Mars would not just change landscapes, it would shape an entirely new branch of human civilization. Children born on Mars would grow up under a smaller sky. The sun would appear smaller, dimmer. The horizon would feel closer. Gravity would always be lighter, every movement slightly easier, every jump a little higher. Over generations, these differences would shape bodies, cultures, and identities. Martians might no longer see themselves as settlers from Earth, but as natives of a new world. Education on Mars would be different from the very beginning. Not survival knowledge would be as important as mathematics or language. Children would learn how life support systems work before they learn history. Understanding air, water, energy, and systems maintenance would not be optional, it would be a basic survival skill. Every citizen would, in some way, be an engineer, a biologist, or a systems operator. As Mars becomes more stable, cities would expand. What began as sealed habitats would evolve into open environments beneath artificial skies. Forests engineered to survive low gravity might grow under transparent domes. Rivers could flow through valleys shaped by human design. Entire ecosystems could be created from scratch, carefully balanced, carefully monitored, and always fragile. But with growth comes conflict. A new world would not be free of politics, power struggles, or inequality. Questions would arise. Who controls the resources? Who governs the planet? Does Earth still have authority over Mars, or does Mars eventually claim independence? History suggests that distance breeds identity, and identity often leads to separation. A future Martian society might reject Earth's mistakes. It might ban certain technologies, limit population growth, or structure its economy around sustainability rather than endless expansion. Or it might repeat the same cycles of exploitation, just on a new world with new stakes. There's also the question of evolution. Over hundreds or thousands of years, human biology may begin to adapt to Mars. Bones could become lighter, muscles could weaken or change, vision might adjust to different light conditions, even reproduction could evolve under lower gravity. At some point, the difference between Earth humans and Martian humans might become more than cultural. It could become biological. And then comes the ultimate question. What happens when two branches of humanity no longer fully understand each other? Mars could become a mirror reflecting humanity's greatest hopes and its deepest flaws. A civilization built from the ground up offers a chance to do things right, to build fairness into the foundation, to respect planetary limits, and to value cooperation over competition. But it also carries the risk of repeating old mistakes on a grander scale. Beyond Mars lies an even bigger implication. If we succeed there, then no world is truly unreachable. Terraforming Mars would be proof that intelligent life can reshape entire planets. That knowledge would echo across the cosmos. It would redefine what it means to be a civilization. But with that power comes responsibility. The ability to create worlds also means the ability to destroy them. The same technologies that warm planets can ruin them.
The same systems that sustain life can be weaponized. So, the future of Mars is not just about science or engineering, it is about wisdom. In the end, Mars may become a thriving second home for humanity, a place of art, culture, and discovery. Or it may remain a warning carved into red stone, reminding us of ambition without restraint. The story of Mars is still being written, and the most important chapter has not yet begun. The one where humanity decides not just how far it can go, but who it chooses to be.
In the end, the story of Mars is not really about Mars at all. It is about humanity standing at the edge of its own future, looking outward and inward at the same time. Terraforming Mars would be the greatest engineering project ever attempted. It would take centuries, perhaps millennia. It would demand patience beyond a single lifetime, cooperation beyond borders, and responsibility beyond profit or power. No empire, no nation, no generation could claim ownership of such a project. It would belong to civilization itself. And that may be the hardest part. Human history is shaped by short-term thinking. Empires rise and fall. Technologies are built, exploited, and abandoned. But terraforming a planet demands something radically different, a commitment to continuity, a promise that people centuries from now will continue a vision they did not begin. Mars would force humanity to think in terms of millennia, not election cycles. It would also force us to confront our relationship with nature. On Earth, we inherited a living world. On Mars, we would be creating one. Every river, every forest, every breathable breeze would be the result of conscious design. There would be no illusion of separation between humanity and the environment. Every mistake would be visible, every success earned. In that sense, Mars could become humanity's greatest teacher. But there is also a darker possibility. What if we fail? What if the planet resists our efforts? What if the cost, ecological, moral, or human, proves too high? A half-formed Mars could become a monument to overconfidence, a reminder that intelligence alone does not guarantee wisdom, that just because something can be done does not mean it should be done. And yet, progress has always been driven by those willing to step into the unknown. Every great leap in human history began with uncertainty. Crossing oceans, reaching space, splitting the atom. Each time, humanity stood at a threshold, unsure whether the next step would lead to enlightenment or destruction. Mars is simply the next threshold. One day, perhaps thousands of years from now, a child may stand beneath a pale pink sky, breathing air that did not exist naturally, walking on soil shaped by countless generations before them. That child may look up at the stars and see Earth not as a home, but as a distant ancestor, a blue light in the sky that began it all. And in that moment, the question will no longer be whether terraforming Mars was possible. The question will be whether it was worth it. Because the true measure of our success will not be in how many worlds we change, but in whether we learned to change ourselves along the way. The future of Mars is unwritten. The future of humanity is unwritten. And perhaps, for the first time, they are the same story. Some scientists believe that we have no moral right to alter another planet. To change Mars is to impose our will on a world that evolved on its own, in its own time, and under its own laws. It may hold clues to the origins of life, or perhaps even microbial life that we have yet to discover. By terraforming it, we could erase that legacy forever. The question is not only technical, it is ethical. What gives us the right to rewrite the history of an entire planet? Others argue that terraforming Mars is not just a possibility, but a necessity.
Humanity is a fragile species tied to a single world. Earth faces climate change, asteroid threats, and eventual cosmic events beyond our control. Expanding to Mars could ensure that life, human life, continues even if Earth becomes uninhabitable. In this view, Mars is not just a planet to be changed. It is a lifeline for our species, a second chance for survival. The truth is, no one knows for certain what the right choice is. Mars could become our second cradle, a thriving world where future generations live freely, explore, and create civilizations unimaginable today. Its valleys and deserts could bloom with engineered forests, flowing rivers, and cities built to harmonize with the land. Humans born on Mars might grow taller, stronger in ways different from Earth-born humans, developing a culture entirely their own. But there is also the risk of failure. Terraforming is a process that would take centuries, perhaps thousands of years. Every decision, every error could have consequences that ripple across generations. A half-transformed Mars could become a barren warning, a monument to ambition without foresight. We may spend centuries trying to create a world that refuses to fully cooperate, draining resources and testing the limits of human patience. And yet, history shows us that humanity is drawn to challenges beyond our immediate reach. Every great leap forward, crossing oceans, reaching the moon, splitting the atom, was born from curiosity, necessity, and the willingness to face uncertainty. Mars represents the ultimate challenge. It asks us to imagine what we can become, what we can create, and what we are willing to risk. In the end, the question is not only about Mars, it is about ourselves. Are we responsible enough to shape a planet? Are we wise enough to avoid repeating the mistakes we made on Earth? Could Mars teach us to live sustainably, to value life in all its forms, and to think beyond a single generation? Or will it simply amplify our flaws, giving us a new world to exploit? Mars could become our second cradle, a new beginning for humanity, or a stark reminder of our limits. And perhaps that is the point. The planet challenges us to reflect, to question, and to choose carefully. Its fate is intertwined with our own. The way we approach it will define not only the red planet, but the legacy of our species. Mars may be far, distant, and silent, but it waits patiently, inviting us to act wisely. And the ultimate question remains, is it worth doing? The answer, perhaps, will come not from technology or science alone, but from the choices we make and the kind of beings we decide to become. Mars could become our second cradle or the greatest failure in history.
Terraforming Mars is not science fiction. It is not a distant dream reserved for stories or imagination. It is a question of time, technology, and human determination. Every discovery, every step forward in space exploration, every experiment in planetary science brings us closer to the possibility that one day Mars could become a new home for humanity, a place where rivers flow again, forests grow under alien skies, and future generations walk freely on a world reshaped by their ancestors' vision. But with this possibility comes responsibility. Mars is not ours by right. It is a planet with its own history, its own secrets, and perhaps even life forms we have yet to discover. The choices we make now in how we approach exploration, colonization, and terraforming will echo across centuries. Will we act as creators, careful and wise? Or will we repeat the mistakes we made on Earth, imposing our will without foresight? This is a question not just for scientists or engineers, but for all of us. What kind of species do we want to be? Are we explorers who respect the worlds we encounter, or conquerors who leave nothing unchanged? Mars challenges us to think, to dream, and to choose carefully. And now it is your turn to join the conversation. What do you think? Should humanity attempt to reshape other worlds, or is it better to preserve them as they are,
as untouched natural wonders. Share your thoughts in the comments below. Subscribe to the channel if you want more videos about space, exploration, and the future of humanity. Your opinion matters, your curiosity matters, and together we can imagine what it truly means to reach for the stars. Mars awaits, silent and patient, and the story of our future may well be written among its red deserts and pink skies.